these smart people built a star on Earth.
In reaction that produced more energy.
A temperature of over 100 million degrees Celsius.
Japan just switched on the world's biggest and most advanced fusion reactor. It's a total game changer, hidden inside a massive donut-shaped chamber called a tokamak.
Scientists have produced a nuclear fusion reaction, resulting in a so-called net energy gain. Simply put, they reproduce the power of the sun in a laboratory.
This reactor locks in blazing hot plasma with powerful magnets. With this reactor kicking off successfully on October 26, 2023, it might just revolutionize how we power our world. But what if this sparks a drastic shift in global power dynamics? Join us as we uncover what Japan's massive fusion technology breakthrough could mean. The fusion breakthrough in Japan's scientific frontier. The success of JT60SA could also lead to faster advancements in fusion technology, making clean energy more accessible sooner than expected. This project highlights the importance of international collaboration in tackling big challenges like energy production. By working together, scientists from Japan and around the world are making strides toward a future where fusion energy could become a reality. The journey is still long, but each step, like the first plasma creation, brings us closer to a breakthrough in energy that could benefit everyone. When this fusion happens, it releases a huge amount of energy. This energy is incredibly useful for both scientific research and practical applications. The successful operation of JT60SA is a big step forward in understanding and using this powerful reaction. For fusion to occur, these nuclei must get very close to each other, so a strong nuclear force can overcome their repulsion. This process requires confining the nuclei in a small space to increase the chances of collisions. In stars like the Sun, this fusion process is driven by the immense pressure from the star's gravity. But here's the interesting part. The idea of using fusion energy for human purposes began in 1925. British scientist Arthur Eddington suggested that stars get their power from the fusion of hydrogen nuclei into helium. This discovery sparked interest in copying these reactions to create a powerful, clean energy source on Earth. Fusion offers the possibility of almost endless energy if we can control it properly. Scientists are still working hard on this, hoping to achieve stable and controlled fusion to power our future. Despite decades of research, creating controlled fusion on Earth has proven incredibly difficult. The extreme temperatures and pressures needed are hard to replicate outside of stars. However, the potential rewards keep scientists pushing forward, aiming for a breakthrough that could change how we produce energy forever. The early 1950s, scientists started looking into the idea of using fusion power, which is the same process that powers stars, to create lots of energy here on Earth. This concept has fascinated scientists and researchers for years. Unlike traditional nuclear reactors that use fission, which splits uranium atoms and creates a lot of radioactive waste, a fusion reactor would use hydrogen isotopes. This method is much cleaner because it produces far less radioactive waste. The path to fusion power is tough but full of promise. Clean energy from fusion. However, the journey hasn't been easy. Scientists have faced many obstacles in making fusion a practical energy source, but they continue to push forward, driven by the promise of a future where we can rely on clean, virtually limitless energy. If they succeed, it could mean a big shift in how we produce and use energy, making our planet a cleaner and better place to live. Unlike nuclear fission, which we use in today's nuclear reactors, nuclear fusion offers a much stronger energy solution. It can produce 4 times more energy per kilogram of fuel and about 4 million times more energy than burning coal or oil. This huge energy comes from the same process that powers our sun, where hydrogen atoms combine under extreme pressure and heat to form helium, releasing a lot of energy. If scientists and engineers can make this process work on a large scale, it could change how we produce power. It would greatly reduce our use of fossil fuels, which are bad for the planet and provide a stronger and longer-lasting source of energy. This could greatly change the world economy, lowering energy costs and increasing access to power in remote and underserved areas. Despite the technical challenges, the pursuit of nuclear fusion is driven by its promise to fundamentally change our energy systems. As research continues and technologies evolve, the dream of a fusion-powered future remains a strong goal, one that holds the key to a cleaner, more sustainable world. The latest designs in energy production use a mix of tritium and deuterium, also known as heavy hydrogen. This new approach shows that a single person in a developed country could generate about 1 terawatt of energy, which is equal to 6 years of power, using just a few grams of these materials. Fusion fuel, which includes tritium and deuterium, is not hard to find. Tritium can be made by combining neutrons produced from fusion with naturally available lithium. Deuterium, on the other hand, can be easily extracted from seawater, making it a readily available resource for energy production. But this isn't the most surprising part. This method promises a sustainable and powerful source of energy that could completely change how we power our world. By using these materials, we could potentially meet our energy needs in a much cleaner and more efficient way. Millions of years will pass before we run out of these fuel reserves. Plus, future fusion reactors are not expected to produce much radioactive waste. These reactors are very safe because fusion can only happen under specific conditions. The plasma will naturally shut down if there's an accident or system failure. It loses its energy very fast and goes out before any significant damage can occur to the reactor. This means there is no risk of a runaway reaction or meltdown because the fusion process is hard to keep going. Global teamwork brings us closer to new energy solutions. The fusion revolution, a safe energy future. The built-in safety features of fusion technology mean that if something goes wrong, the plasma cools down and stops working quickly, making it a very safe way to produce energy. As research continues and technology improves, these reactors are set to provide a reliable and long-term solution for the world's energy needs without the risks of other types of nuclear reactors. But that's not the best part. These advancements promise a future where energy is both safe and abundant. With every step forward, we get closer to a cleaner, safer energy source for everyone. Starting and maintaining nuclear fusion, like fishing, doesn't produce any greenhouse gases. This means that by the end of this century, nuclear fusion could become a major source of low-carbon electricity. While the sun makes nuclear fusion look easy with its strong gravity, doing it on Earth is much harder. On Earth, we need temperatures even higher than the sun's to fuse deuterium and tritium, two types of hydrogen. On our planet, we need temperatures over 100 million degrees Celsius to achieve fusion. Besides these extreme temperatures, we also need to control magnetic forces and keep the right pressure to stabilize the plasma. This stability is key to keeping the fusion reaction going long enough to produce more energy than we used to start it. Even though current experiments get close to the conditions needed for a fusion reactor, controlling these elements must be perfect and continuous. Scientists are constantly researching and experimenting to harness the power of fusion, hoping for a future where clean and abundant energy reduces our dependence on fossil fuels. Yet, this is not the biggest challenge. Maintaining the necessary conditions for a successful fusion reaction on Earth is still incredibly tough. Despite coming close, scientists need to find a way to sustain these conditions to make fusion a practical energy source. This ongoing work offers hope, but the path to success is filled with obstacles. Understanding how to keep the plasma stable and control its confinement is key to sustaining the reaction and generating energy. This is part of the worldwide effort to achieve net fusion energy. Scientists and engineers from all over the world are working hard to invent new materials and design innovative systems to reach this goal. More than 50 countries are involved in research related to nuclear fusion and plasma physics. Recently, scientists made a significant breakthrough by achieving a net gain in energy from a fusion experiment for the first time. This milestone was possible because of the development of various designs and magnet-based fusion devices like tokamaks and stellarators. These devices are crucial for ongoing experiments and the overall progress in fusion energy. As scientists around the world keep innovating and testing these new technologies, the chances of harnessing nuclear fusion's power grow. This could lead to a revolutionary source of clean energy in the future. One important part of this big puzzle is the JT60SA, a unique device that's different from other large tokamaks. It's designed to push the limits of what we can do with fusion energy. The challenge isn't just about the technology, it's also about the global teamwork needed to make this ambitious project happen. Fusion tech advances with each global collaboration, the quest for sustainable fusion power. As countries and experts work together, the chance to create a sustainable energy source that could change our energy systems for the better increases. But this isn't the only challenge. The complexity of coordinating all these efforts on a global scale is another big hurdle. The reactor is designed to heat plasma to an incredibly high temperature of 200 million degrees Celsius and keep it that hot for about 100 seconds. This is a big challenge, but it will help scientists find new ways to control and improve how plasma behaves and stays stable. These improvements are very important for making fusion power work. The JT60SA facility will be a key part of helping ITA, a huge international fusion reactor being built in France. This teamwork is crucial because the goal of fusion energy is to produce more power than it uses. ITA's success will depend a lot on the knowledge and technology that the JT60SA can offer through detailed testing and checks. But that's not all. Japan got permission to build JT60SA and 2 smaller fusion research centers. This permission was part of a deal that also allowed France to host the ITA, which is the biggest fusion experiment ever planned. This agreement, made in 2007 between the European Union and Japan, sets up a big leap forward in fusion technology. It could change how we produce clean energy around the world. However, there's more to the story. The collaboration between these countries is more than just sharing space and resources. It represents a commitment to a shared goal of developing a sustainable and powerful new energy source. This partnership highlights the global effort required to tackle the challenges of creating efficient fusion energy. Alberto L., who leads ITA's science division, said that the data from JT60SAA's plasma experiments would be very useful for improving research at ITA. This upgrade shows Japan's dedication to improving its technology and helps the world learn more about plasma science. But that's not the most interesting part. This upgrade also plays a key role in advancing our global knowledge of how plasma works. The James Webb Space Telescope's journey to completion took over 15 years, much longer than initially planned. Originally set for a 2016 launch, the project faced many challenges. Procurement issues led to several pauses and changes to the original plan. The devastating Tohoku earthquake in March 2011 forced the engineering team to rethink their design. They had to redesign parts of the telescope to ensure it could withstand similar shocks in the future. This redesign was crucial for the telescope's safety and functionality. In March 2021, during some tough tests, a big problem appeared. A short circuit happened in the cable connected to one of the superconducting magnetic coils. This was more than a minor issue. It caused significant damage to the electrical connections and led to a helium leak. This leak was a big deal because it could mess up the cooling systems essential for the telescope's operation. The James Webb Telescope's journey shows resilience and innovation. The challenging path to the stars, These incidents show the tough and tricky path the James Webb Space Telescope had to travel from the idea stage to nearly being finished. Each challenge needed a quick and clever solution to keep the project moving forward. This journey highlights the resilience and dedication of the scientific community involved in this groundbreaking endeavor. The QST project manager, Yoshiyuki Sakai, said the situation was critical. The coil could have been severely damaged if the electrical current had been higher. He felt relieved, knowing they avoided a potentially disastrous outcome. The team working on the JT60SA reactor had spent 2.5 years improving the insulation on over 100 electrical connections to enhance safety. This incident has led the ITR developers to introduce stricter testing protocols for their coils to avoid similar problems in the future. One major issue with the JT60SA model is that it relies only on hydrogen and its isotope, deuterium, instead of using tritium. Tritium is more effective and desired for electricity generation because it produces more energy. However, it is much more expensive, less available, and highly radioactive. Despite these challenges, ITER plans to start using a deuterium-tritium mix from 2035 to make the reactor more efficient. But that's not the worst part. Switching to tritium brings its own set of problems. Looking ahead, Japan plans to build a new type of power station by 2050 called DEMO. This facility is seen as a crucial step in connecting current energy production technologies with future advancements. This strategic development aims to strengthen Japan's position as a leader in nuclear fusion, promising a more reliable and sustainable energy future. However, the journey to 2050 is filled with challenges and uncertainties. JT60SA and ITER are like two giants in the world of nuclear fusion, each playing a unique role in the push to unlock a powerful, clean energy source. JT60SA, located in Japan, serves as a crucial supporting act to the ITER project in France. Both projects aim to master the art of fusing atoms to release massive amounts of energy without pollution, much like the sun does. JT60SA is especially designed to tweak and refine our understanding of high-temperature plasmas, the hot, charged gases at the heart of fusion reactions. This tokamak, a type of fusion device, can control plasmas up to 200 million degrees Celsius and maintain them for up to 100 seconds. Such extreme conditions are essential for fusion to occur, and learning to manage them paves the way for sustainable energy generation. Unlike ITER, which will eventually use a mixture of two hydrogen isotopes, deuterium and tritium, JT60SA starts with hydrogen and later uses deuterium. This strategy keeps the facility less radioactive, making it easier and safer to modify and experiment with as scientists learn more from its operations. This flexibility is vital because it allows the facility to adapt and evolve based on new discoveries and improvements in technology. Moreover, JT60SA isn't just about conducting experiments. It's also a breeding ground for future nuclear scientists and engineers. This emphasis on education ensures that the project not only advances our current understanding of fusion, but also prepares the next wave of experts needed to continue this challenging work. In collaboration, JT60SA and ITER are more than just research facilities. They are beacons of hope for a future where clean and abundant energy could solve many of the world's environmental and energy challenges. Their work supports not only the technical aspects of achieving fusion, but also contributes to global efforts aimed at reducing carbon emissions and combating climate change. The achievements of JT60SA, from its advanced handling of plasma to its role in international education and collaboration, make it a cornerstone in the global pursuit of fusion energy. As both JT60SA and ITER advance, they not only inch closer to their goal of replicating the sun's power on Earth, but also inspire a new generation of technologies and energy solutions that could transform how we power our world. Will fusion energy truly revolutionize our future, or is it an overhyped dream? Like, leave comments, and subscribe for more.